Hello everyone, my name is Kunal and I'm your mathematics tutor. And today we are going to start our new chapter, which is definite integration. So first I'm giving you some approach like what is definite integration and how is different from indefinite integration. So like we know that in indefinite integration of like if we integrate x with respect to dx, so here nothing are written, there nothing is written. That means limit are not given. So we integrate it and so this is our result. That means in indefinite integration, limits are not given. But in definite integration, limits are given. So what happens when limits are given? We actually deal with it when limits are not given. So हमने जो पहले पढ़ा था indefinite integration, so in that limits are not given, but now we have to read if the limits are given in integral, so how to deal with those kind of things. So first we have to know there is a certain condition, like if we are integrating a function from fx of x, this is our function, given function, from a to b. This is our x, which varies from a to b. So the condition is fx must be continuous in must be continuous in x belongs to a to b. I hope you'll all know what is continuous thing in continuity and differentiability chapter. So the condition is the fx must be continuous from in x belongs to a to b, and fx is equal to f dash x. Let me suppose that uh, like fx is differentiation of fx function, right? So what we can write then, we can write it as a to b and fx dx is equal to fx a to b, and then we have to put limit. So first we have to put the upper limit and then we have to put the lower limit. That is fb minus fa. So let me write the syntax here. So the syntax is we have like our final integral is fb, fx, right? And from a to b, so we have to write upper limit minus lower limit. So this is the syntax of insert the limit in final integral. Whatever we got, like if some integrand is given, so as usual we integrate in indefinite integration, we do the same process or we apply some property here too, we will read later. But first on how to insert the limit in final integral. So the syntax is we have to first insert the upper limit and then we have to insert the lower limit. So this is known as lower limit and this is known as upper limit. In integral, this is our the value of x which written in the tail of the integral sign is known by lower integral, lower limit, sorry, and this is as upper. I hope you'll all understand. So let me show you like how to apply. How to apply, I am showing you by example. So let us see example how to apply this. Example one. So let us suppose we have to integrate x square dx from 2 to 3. So first identify which one is our lower limit and which one is upper limit. So we can write it here as lower limit given is 2 and upper limit is 3 because it's in with the tail and it's in with the head of the integral sign. So we know the integration of x square, it would be form like x to the power n. So its integration is x to the power n plus 1 by n plus 1. So we have to write x cube by 3 and we have to put limit. So the syntax is first upper limit we have to put. So first insert this and minus this. So we have to write like 3 whole cube by 3 minus 2 whole cube by 3. So when we solve this, we get 9 minus 8 by 3. It's something look like 19 by 3. So I hope you understand. So what I am aiming to show you this example. So my aim is to show you how to apply the limit in the final integral. So I'm again telling you, first we have to put the upper limit and then we have to put the lower limit. So the upper limit is 3 and the lower limit is 2. So we first put the 3 at the place of x. So it will be like 3 to the whole cube by 3. And then we have to subtract and put the lower limit. So it will be like 2 to the whole cube by. Let me show you another example of some trigonometric function. So it will be seems like if our function is sine of x, we can write it as sine of x from 0 to pi by 2. So we know that uh, our lower limit here is here. Lower limit is 0 and upper limit is pi by 2. So we know that the integration of sine x is minus cos x. So we have to put the limit from 0 to pi by 2. So we have to first put x is equal to pi by 2 here and then we have to put 0. So we know that minus take outside cos pi by 2 minus cos of 0. So we know that cos pi by 2 is 0. It will be like 0 minus and cos 0 is 1. So our final answer is, I hope you'll all understand this, how to insert limit in final integral. So this is our first type, first things that we learn how to insert the limit. Now we move to the geometrical meaning. Like we know that our fx dx, what it represent? It represent the things we get here. This is actually an indefinite integration, right? This is actually an indefinite integration, right? So what it represent? It represent the family of curves which are parallel to each other, right? What it represent? It represent the family of the curve जो कि एक दूसरे के parallel है. So now the question arises, then what represent this? If limits were substituted, so what represent this? So let me show you what represent this. So the geometrical meaning of it, I have to write here. Geometrical meaning of fx dx a to b. Try to remember my first lecture of indefinite integral, which were explaining the meaning of geometrical meaning of indefinite integral. So what it represent? It represent the family of parallel curves, right? Now we are going to study what the geometrical meaning of definite integral. So actually, fx dx from a to b geometrically implies the algebraic sum of area actually. Geometrically implies the algebraic sum of areas. enclosed by continuous function. As I mentioned in the first line, the function, the integrand given should be continuous in A to B. In continuous function, fx with x-axis from x is equal to from x is equal to A to x is equal to B. So it represents basically area. What it represent? It represent the algebraic sum of area enclosed by the continuous function. So let me show you by figure, right? So, okay, let me show you. First, erase this and let me make here the axis. So this is our x-axis and this is our y-axis. Okay. So let us suppose that our area, uh, not our graph of fx will something. Okay. Suppose our graph of fx seems like this. Okay. Suppose that our graph of fx look like this. So we have certain area. So let me show you by different colors. So let us suppose our first area, this. This part of the curve lies above the x-axis, right? And this part again lies lower the x-axis, right? Let me make it clear. Okay. And the third part, which again lies above the x-axis. Okay. So what we notice here, like this is our x is equal to A, and this is our x is equal to B. So our function fx seems continuous in x belongs to A to B, right? And so we have some area here, like we claim this part as A1, this part as A2, and this part as A3. I mean, if you look carefully the graph of fx, so it seems like x belong to A to some x, named it as x is equal to B, B dash actually. So x is equal to A to B dash. Our area, our graph lies above the x-axis, and from B dash to named it as C dash, and B dash to C dash it lies lower the x-axis, and from C dash to B it lies above the above the x-axis. So what I'm trying to say, it represents the our fx dx from A to B represent this sum of these area, like A1 plus A2 plus A3, the area of the part, this area of the part, this, and area of the part, this. Whatever we get here, we and when we add these all, we get the value of integral of fx dx from A to B. Oh, sorry, I do mistake some here. There will be minus because it's algebraic sum, no? So it will be minus because it's lies below the x-axis. So it will be subtracted. Okay, so this is our geometrical interpretation of definite integral. Let me explain you again. What I'm trying to say is there are two part of first we assume the uh, graph of fx will seem something look like this. Okay, some part lies above the x-axis, some part lies below the x-axis. So I am assuming like two part lying above the x-axis and one part lying below the x-axis. So what I'm trying to say is the geometrical meaning is basically the algebraic summation of area in A to B. So when we see the two parts is above the x-axis, so both were going to add, and the part which lies below the x-axis, so it will be subtracted. So it will be seems like A1 plus A3 minus A2. So you have to all uh, go through it very, very carefully. It's a chapter of very careful in which we all have to always see each and every single cases. Like we can't left anything, but otherwise we not reach the final answer. Let's move to the some example of showing how it show the area. So let me write here example. If I am showing same thing, like I'm integrating a function sin x dx from 0 to pi by 2, right? So let me show you by geometrical, and we know that its answer is something minus of cos x. Uh, its integration is minus of cos x, and when we insert the limits in it, so we get the value 1. So how it represents geometrical? What its geometrical meaning? So let me show you. So first draw the graph of sin x. So if we draw the graph of sin x here, x, y, we know that the graph of sin x will something look like that. And sorry for my drawing. Okay, so 0, it seems like pi, it seems like 2 pi. This is our pi by 2, at which the value is minus 1. Sorry, plus 1. Here the value is minus 1. Okay, so we have to find the area from 0 to pi by 2. So we have to find the area. Let me choose some other color. It's not. Okay. So we have to find this area actually. Of, we have to find this area actually. And if someone tell you what is the area between 0 to pi by 2, so we find it mathematically by integrating it. So we get the value 1. So what we can understand, the area of this region is 1 square unit, right? Area of this region is 1 square. We can't, like, if certain rectangle is formed, we know its formula area. L into B square is given. We know its area. It's cuboid is given, so we know the total surface area will be 6a square, a side. But how we find area of an certain irregular figure or regular figure which were not actually uh, in solid phase like this? So we have to integrate those. So this represent Like I show it by mathematically. So what I'm trying to say, so here you by this example. So our main motto is to show you like if we find the integration of sin x from 0 to pi by 2, x is equal to 0 to pi by 2, its value is 1. Mathematically, it's so, right? We use some mathematical, like we use the integration of sin x is, we know it's minus cos x. And then we do some mathematical calculation and we reach to the answer 1. But what it represent? It represent the area in the graph of sin x from 0 to pi by 2, like this area. Okay. So actually, now let's move to the same problem, but we just change the limit. This time we understand from, let me write here, understand from mathematical to geometrical, right? In this example, we understand mathematical to geometrical. In this, we understand from geometrical to mathematical. Both were valid, geometrical to mathematical. Let me take the same example of sin x dx. We have to integrate sin x dx, but from 0 to 2 pi. I change the limit. So let me draw this time. First, we use graphical method or geometrical, if whatever you want to say, you just say. So if I draw the graph of sin x in between 0 to 2 pi, so what I get, this is 0, this is pi, and this is 2 pi. If you see carefully, we know that the we have two parts. Again, we have here two part. This is our first part, which this is our actually first region which lies above the x-axis, and this is our second region which lies below the x-axis, right? So we know that the integral value will be some algebraic summation of area. So let us suppose if this area is A1 and this area is A2, so graphically A1 minus A2, and both were same, both were graph are symmetrical. Graph is symmetrical. So we can say that its area is 0. Its net area is 0. Okay, use the word net. Net area is 0 because graph was symmetrically upward and symmetrically downward. So both area was same. So we get when we add algebraically, it will get we will get 0. I hope you'll all understand what I'm trying to say is I just add the both area of the region with opposite sign because one is above the x-axis and one is below the lower x-axis. Now try to find the same by mathematically. Now we proceeded through mathematically. So what we know, sin x dx, we have to integrate from 0 to 2 pi. And we know the integration of sin x is minus cos x. And we have to just insert the limit in it. So first we have to insert upper limit. So cos of 2 pi minus cos of 0. And then we have to put the cos of 0. And the both value will 1. Oh my God, we get the same thing, right? So here what we understand from graphically to mathematically. Both were valid and दोनों का मैंने दिखा दिया कि ये क्या represent कर रहा है, right? I hope you'll all understand. So let me make you something, some things were clear. Like ये चीजें समझ में आ गई होंगी, मैथमेटिकली to graphically and graph to math. Both were same. Now let's move on to some. Try to note, like if this is our, like this is A and this is B, right? This is x-axis and this is actually required area. Okay, this is our required area. So, and this is our function fx. So, integration of a to b fx dx is positive. Okay, and which is equal to a, whatever it is, because area given is a, so it's a, right? And second thing you have to notice, this is our x-axis, and let us suppose this is our graph. There is A, there is B. So this is our region, and its area given is A, but it slides below the x-axis. So A to B fx dx is negative because it slides below the x-axis and its value is minus of A. Okay, so this thing you have to keep in mind. I hope you'll all understand this, what I'm trying to say. Let's move on to now properties, right? What are the properties of definite integral and so properties. So our first property will look like if we integrate a a function which is continuous in x belong to a to b, ये सब जगह होगी. Like this is our function fx dx. We are integrating from a to b. It is same as when we integrating from b to a, but with negative sign fx dx. Here I have to write fx is continuous in x belongs to a to b. Okay. I hope you'll all understand this. So I will prove it later. First, I have to write the property here. Now the second property is, which is a to b fx dx, where again a function which is continuous in x and x belong to a to b. So it will be equal to a to b ft, right? It will be equal to ft dt. So let me try to prove it. So our first property shows like integration of fx dx from a to b is equal to minus of integration of fx dx from b to b. So if you analyze something here, हो क्या रहा है यहाँ? If you look into it carefully, we get the lower limit. This is our LHS, right? Lower limit is A and upper limit is B. And what happened in RHS? In RHS, the lower limit is B and upper limit is A, right? It just उल्टा हो गया ना. So basically, I am saying कि let us suppose integration of fx, or we can write it as fx is equal to f dash of x, or we can write it as integration of fx dx is fx. Okay, so when we substitute the limit, we are actually going from LHS. Okay, we are actually going from LHS. So fx ab. So what we get, we have to first insert the upper limit, and then we have to insert the lower limit. So we get fb minus fa. This is our equation 1. Now move on from RHS. So again, it will be fx, but here the lower limit is b and upper limit is a. So we have to first insert the upper limit. So what we get? fa minus fb. So we can write it as minus of, if we take minus common, what we get? fb minus fa. Now it's clear, both are same, fb minus fa, fb minus fa, but in RHS we get the negative sign. So now it get clear, like LHS is equal to minus of RHS. So integration of fx dx from a to b is equal to integration of fx dx from b to a, just with negative sign in front of proof. Okay, so this is actually first property get true. Now let's move on to some new thing, which seem as what, let us suppose a graph of a function. Graph of a function uh, will look like something like that. And why same fx? This is our fx function. Fx is continuous in x belongs to a to b. Uh, this is our x is equal to a. This is our x is equal to b. So we know that if a function, like the value of the function is get 0 at some point, right? Let us say it is x is equal to c. So if we look the graph carefully, we can understand that at x is equal to c, fx is equal to, which is actually fc is equal to 0. At x is equal to c, the value of fx is 0. right? At x is equal to c, the value of fx is 0 if you look carefully here, right? Here value is 0. So what can we understand from this? And if this area is A1 and this area is A2, or if the graph was symmetrically, so if graph is symmetrical, if graph is symmetrical in A to B, so we get fx dx from A to B is equal to 0, right? So there is a conclusion. And what is it? If uh, if fx dx in A to B is equal to 0, then fx must have at least a root in A to B, provided fx is continuous. Fx is continuous in x belongs to A to B, right? So like here we above we saw that how is it possible? So there must be a root. Like if you look the graph carefully, if the graph is symmetrical, so the if this area is and this area, and we know that the integration of fx dx from A to B is nothing but the algebraic sum of area of each cross section, right? So if we add that, we get area 0. That means net area 0. So that means integration of fx dx from A to B is 0. So what it represents, there is a value at some c, there is a value of x, let us called c, where our function value what? 0, right? There is some value where our function value get 0. So what can we say? If so, the conclusion explains that if fx dx from A to B must have at least a root, कम से कम एक root तो होगी in A to B, provided fx is continuous in A to B. I hope you all understand this. It may be like if the graph is something, let me show you. If the graph of fx and it, so like this is and this and these all are different color represent like graph is unsymmetrical, right? In above problem, we considered the graph is symmetrical. But now we consider the graph is unsymmetrical. Let's draw it like this. And something color by black. Okay. So what I'm trying to say, this area called be A1, this area A2, this area A3, this area A4, this area A5, this area A6, and this area is A7. So we know that, and this is the, this is A, this is B, fx dx, and it seems like it's continuous in A to B. So what is it? Our area is A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7. And if somehow it is equal to 0, like net sum of this will be 0. So what we can say, there is a C which belongs to A to B lies such that FC value is 0. Let me write here, there is minus, there is plus, there is minus, there is plus, there is minus. I hope you'll all understand. So let me write here the value first. Like this is C, D, E, F, G, H. So there are C, D, E, F, C, D, E, F, G, H. 1, 2, 3, 4, 6 values lies between A and B, where fx value is 0. जहाँ पे 6 वैल्यूज हैं लाइक सी डी ई एफ जी है जहाँ पे fx की वैल्यू 0 हो रही. सो व्हाट्स आवर कंक्लूजन से, देयर lies at least one value between A and B जहाँ पे fx will be 0. So our conclusion remain valid here. I hope you'll all understand this, what I'm trying to say. There lies the 6th value, right? Like if we draw the graph of fx in such a way, let me make it clear, then you will all understand. Okay, so let me write it clear. Okay. Such that A, B, C, D, G, H, and then like this. So you can say that graph किसी तरीके से भी हो सकता है. So our main things is कि if the fx dx from A to B, anyhow it will become 0. So there lies a C between A to B where fx is 0. That means there at least a root of fx between A and B. So we can say that. Like let us take the example of sin x here. The basic function. We always take sin x because its graph is simple now. We can take different function too. So let us take sin x. Yes. From 0 to 2 pi. We आज ही हमने देखा है कि इसकी it will be like that 0 to 2 pi and it is symmetrical, right? It is symmetrical, and we know that this is our A, this is our B, this is our A, this is our B, and we know that this is our pi, and we know that the area is 0. That means mathematically its value is 0 because this part is A1, this part is A2, and when we and graph is symmetrical, so it's 0. So what I'm trying to say is this is actually pi, right? So if you look at here, there is a value of x which is pi, which lies between 0 to 2 pi, where sin x is 0. Like if we put sin pi is 0 now, so and the pi lies between A and B, where A is our 0 and B is our 2 pi. So our conclusion is valid, right? I am trying to show you by drawing the actual function graph. Like in above, we assume the function look like this way. But here I just took the function of sin x and draw its graph. And then I'm trying to show you, like if the definite integral value got 0 in any A to B, between any A to Bx, so there lies a C between A and B where the value of the function is 0. That means there at least a root lies between that A and B. And we look at through this example. So at x is equal to pi, The value of sin x is 0. So we understand the result in a. So what we conclude here, we conclude the root of sin x between 0 and 2 pi is pi. It holds the valid conclusion. Okay. I hope you'll all understand what I'm trying to say is. So let me show you one more thing here, which something look like if uh fx. Okay, let me clear it with you first. Then I go through this concept. Uh we actually read that if the area is above the x-axis, so it will be positive, and lower the x-axis, it will be negative. So I'm trying to say that if area above x-axis is 2 square unit from its initial position to some x, and area below the x-axis is minus 16 square unit from that x to b, right? So what's the value of integral fx? Let me erase it first. Integral fx dx from a to b. So we know that our final integral value will be like summation of a. So it will be look like a minus a to, it will like 2 minus of 16 will be minus 14 square unit. And if we go through its graph, it seems interesting. Like if someone said draw the graph of the function. So we know that it's very less area. Like if this is our A and this is our B, and there is somewhere between C. C lies between A and B, right? So it is little bit interesting here. The area above the x-axis is very low, right? So our C must be somewhere near to it. And this graph will be like this. And the area below the x-axis is minus 16. So it arrange the huge area below the x-axis, right? This is our A1 and this is our A2. And A1 is very less, 2 square unit. And A2 is our minus of 16 square unit, right? So our function could something look like this. I hope you'll all understand this. So that's all for today's lecture. Tomorrow we'll discuss some more property and try to find the approach how to solve the definite integral. So आज हमने basic definition, geometrical interpretation and some property देखा. And tomorrow we understand how to solve definite integration and more property. Okay, that's all for today. Thank you.